right, let's begin with the introduction to Earth. I've got two short topics that I want to start with. Just kind of basic geography, and I want to go over the Earth's shape. It's obviously round, it's a sphere, but actually it's not perfectly round. The true name of the shape of the Earth is something called an oblate ellipsoid. The word oblate means flattened, ellipsoid means circle. And so the Earth is actually shaped kind of like a flattened circle. It's flattened at the poles with a bulge, equal bulge at the equator. And so that's the actual shape of the Earth. It's not a true sphere. I want to move on to quickly the second topic, the fact that the Earth rotates. All right? And as it turns out, it is the cause of the oblateness for the flattening at the poles and the bulge at the equator. And it comes down to something you've probably heard of before. It comes down to what is known as the centrifugal force. And the centrifugal force states that any rotating body, the mass moves away from the center. All right, if you've ever seen a whirlpool, it's all rotating in the water, and it kind of pulls away from the center. You've seen hurricanes. All right, that's a rotating counterclockwise circulation. It's pulling away from the center, and it's creating an eye. All right, and so the Earth's mass is doing that, and so it is a centrifugal force creating that. It is okay. And another thing about the Earth, all right, that we've got to get straight is that when we're looking at Earth from space, the Earth is rotating always from west to east. Now that's going to be really important in discussing world time. All right. All right. And another thing that everybody knows, I think, is what a day is. All right. It's actually called a solar day. The fact that the Earth rotates, all right, 360 degrees. All right. One complete rotation with respect to the sun in 24 hours. All right. And so that's called a solar day. That's what a day is. All right. Okay. All right. And the thing that's really interesting about the Earth's rotation is how fast it rotates. The Earth is rotating right now at a speed of 1,000 miles per hour. Right? It's like, why aren't we being blown off the surface of the Earth? It's incredible. And the reason comes down to the fact that the atmosphere, right, held in by gravity, the Earth's atmosphere held in by gravity rotates with the Earth. All right, and so since our lower atmosphere extending out to about 50 miles, rotating with Earth, we have no feeling whatsoever of the Earth's speed, and that's pretty amazing. Right? Okay, yeah. So as I said, the atmosphere is rotating with the Earth. All right. Another thing that we'll be talking about in a little bit more detail in the next topic. All right. Here I'm showing the Earth is kind of rotating west to east. And I've got the sun over here, all right? And of course, the sun can only illuminate the Earth, one half side, all right? And the point that I want to make is right all along this line, right, on Earth, directly facing the sun, it's noon, all right? It's noon. And the Earth is rotating now. And so as the Earth is rotating, this location maybe right here is maybe about 1 o'clock. It's a little bit later. 2 o'clock, 3 o'clock, 4 o'clock, and then we're going to get to the dark side of the Earth. All right. And so it's going to be sunset, whatever time that is, 6 or 7 or something like that. And it's going to be 8, 9, 10, 11. It's going to be exactly midnight on the opposite side of the Earth. And then we'll move on into the early morning hours. On the opposite side, we're going to have sunrise, right? And then we'll have the morning hours until we rotate all the way back directly facing the sun until it's noon. And this is something we'll talk about a little bit more, all right? But anyways, another thing about, a final thing really about rotation that's really another critical thing, is the fact that the Earth rotates. It winds up creating two natural reference points on Earth, all right? And those are the poles. All right, the North Pole and the South Pole. And so you can draw an imaginary line, all right, forming the center of rotation. It's called the Earth's polar axis, all right? And it's an imaginary line forming the center of rotation. So in reality, we really wouldn't see the polar axis as, in the center of the Earth. But where the polar axis emerges from the Earth, it creates a natural reference point, all right? And that creates what we know as the North Pole and the South Pole. And so the Earth is spinning, all right, on its polar axis. Okay, and that's it.